Alright, welcome to the video lectures on chapter 10, how to deal with the time value of money. This is related to the finance branch, and it's a very important concept when it comes to making the decision. This week we are really going to nail it. 4 concepts: time value of money, what do we mean by it? Present value of future cash flows, net present value or NPV, internal rate of return or IRR. Start with time value of money. Ignoring time value of money. In the incremental value analysis that we did last week, we have added cash flows across time, ignoring the time value of money. What do I mean by it? See, this is what we did last week. We predicted our incremental benefits, the sale value of assets, working capital, the money you put in, the money you borrow and pay off at the end, the interest you pay, the opportunity cost of capital. And then we said, okay, so first year 20,000 is leaving, second year your net cash flow you are making is this, and we just added everything. Then we said 279,343. Well, the problem is, if there is cost of capital, cash flows across years cannot be compared at the face value. That is, currently when we add everything like this, we are treating this 113,300 as the same as this. We are not differentiating the time value of money. We are only focusing on the value of money. We are not recognizing like this is coming early. For example, this is almost the amount you need to settle this loan. So you see, with this money, you may be able to settle this loan right here. Then you don't have to make these 2 payments. So that's about a $55,000 savings, right? So how can this be the same as this? Because if the money comes here, then, well, you got to pay all these interest and then pay this debt off, right? So when there is cost of capital, the money that comes earlier is more valuable than money that comes later. So we have to find a way to deal with this thing, because currently this calculation ignores the time value of money. Let's say the cost of capital is 20% to keep things simple, right? To settle $1 you borrowed today, so you go to the bank and you borrow $1 today. How much money do you need after 1 year to settle this loan? You obviously need to pay back the capital of $1, and then 20% of $1 is 20 cents. So $1 capital you pay back, 20% of $1, 20 cents interest you pay back, so it's $1.20 is what you need to pay back. But suppose this $1 that you borrowed today you want to pay back only after 2 years. Well, how much will you have to pay? Well, at the end of 1 year you're supposed to have paid $1.20. But if you are not paying that off, it's like you are borrowing $1.20 for that second year. So at the end of the second year you got to pay the $1.20 capital and the 20% interest on that $1.20. So if you add these things, if you pull the $1.20 out, it's 1 here and 20 cents there. And surprisingly, you find that's another $1.20. So that's $1.20 squared. And that's $1.44. So note, you paid 20 cents in interest. The second year you're paying 24 cents in interest, because now you got to pay interest on the interest. But let's say you couldn't settle it in 2 years, you had to wait till 3 years. Well, how much do you have to pay at the end of 3 years? Because now it's like in the third year you're borrowing $1.44 because you didn't settle it in the second year. So at the end of the third year, you got to pay the $1.44, which is the $1.20 squared, plus 20% on that. Now surprisingly, you see, you pull $1.20 squared out, this one and this 20, so that's $1.20 cubed, that $1.73. So now you're paying 29 cents, for that the third year, or between here and here, you have to pay 53 cents. So you see that $1 that you borrowed today, right, it's going to cost you $1.20 settle after the first year, $1.44 to settle after the second year, $1.73 to settle after the third year. Okay, so keep that. $1, you want to settle after 3 years. If your cost of capital is 20%, you need $1.73. Take some time to digest this. Now let's go to a practice question. If the cost of capital is 10%, what will be the value of $1,000 today after 5 years? Right? Or what is it that you need to pay after 5 years? Is it 500, 1,500, or 1,000 times 1.1 to the power 5, or is it 1,000 times 1.01 to the power 5? If you remember our example there, it was $1 will become 1.2 to the power 3 after 3 years, but if it's after 5 years, you see the pattern 1.2 to the power 5, but in our case it's 10%, so it's 1.1 to the power 5, so 1,611. So if you borrowed $1,000 today, and if you want to settle it after 5 years, you got to pay $1,611. If you had paid the interest every year, then you pay $100 every year, $100 every year. You would have paid $500 in interest, and then you pay the capital back. But if you are not paying anything, then at the end of 5 years, you got to pay $1,611. Okay. Now let's go to the idea of present value of future cash flows. Because remember, in the business is going to give you cash flows every year, right? And so we want to ask, what's the value of those future cash flows today? What's the present value, today's value of these cash flows? So to understand that, so we are still assuming that you can borrow at 20%. If I ask you, which do you prefer? Do you prefer $1.73 after 3 years or $1 today? Suppose I bought something from you and I say, hey, in payment, let's say it's a $1 charge, so I can give you $1 today, or I tell you, I'll give you $1.73 after 3 years. Well, what are you going to prefer? It may seem like $1.73 is more than $1, but it's coming after 3 years. But you have a place where you can borrow $1, provided after 3 years you can pay $1.20 to the power 3, that's $1.73. So you would basically say, look, I'm indifferent because I can borrow money at 20% interest. So if you give me $1.73 after 3 years, against that $1.73, I can borrow $1 today from the bank. So whether you give me $1 today or $1.73 after 3 years, for me it's the same thing. That's the idea of, so in your mind you look at $1.73 after 3 years and you say, that's basically $1 today because I can surrender that and borrow $1 against it. So the present value of $1.73 received after 3 years is only $1 today when you have an opportunity to borrow at 20%. Let's just flip this and say you get only $1 after 3 years. what then will be the present value of $1 received after 3 years? That if you're going to get only $1 after 3 years, how much will a bank that wants to earn 20% will be willing to give you? Let's say that is Y. So now what we know is $1, if you borrowed, after 3 years you had to pay $1.73. But you only have $1 to pay. So let's say, how much will a bank give me? So that times $1.73 will become equal to $1. And that implies Y equals 1 over 1.73, or this 1.73 is basically 1.20 to the power cube. That's 58 cents. So you can see, if you have only a $1 to surrender to the bank, bank will give you only 58 cents today. In other words, the present value of that $1 after 3 years, when you can borrow at 20%, is only 58 cents, because that's what you can borrow against that dollar. What then is the present value of $1 received after n years? Now let's say it's not 3 years, it's going to come after n years. N can be 5, 6. So you see the pattern now. It's 1 over 1.2 to the power n, right? If n is 3, it's 58 cents. If n is more, you would see further down the $1 is going to come, this number will keep coming down. Right? Because bank says, oh, if you're going to pay me back only after 18 years, then I got to charge you a lot of interest, and I'll be willing to give you a very small amount today. Suppose cost of capital is R%. So far we have assumed 20% is general, and this $1 is going to come after n years. So how much will a bank give you today, or what is the present value of it when your cost of capital is R%? Right? Then now you see, instead of 1 over 1.2, because it was 1.2 because it was 1 plus 20%, but now if it is R%, it is 1 plus R, and whenever this is coming. So you would see, so this is called discounting. The future cash flow is discounted for two reasons. How far off it is coming, then the value is less. And what is your cost of capital? You know, if the bank wants to charge you a lot of interest, it will be willing to give you much less. So you see, as the discount rate goes up, or the number of years after the dollar is coming, the present value would be much smaller. So what is the present value of a general X dollars received after n years? Because remember, in our business, money is coming after year 1, year 2, year 3, and a lot of money coming after year 5. Well, it's simple. If $1 received after n years is 1 over 1 plus R to the power n, X dollars received after n years is just X divided by that. So what is the present value of $2,000 received after 3 years when R is 20%? Is 2,000 divided by 1.2 to the power cube. That's 11,057 and 41 cents. What's the meaning of it? If business is going to give you $2,000, and if you tell the bank, hey, I'll surrender that payment to you, a bank that wants to earn 20% return on you would be willing to give you 11,057 41 cents. So you look at that $2,000 payment after the third year like 1157, because you can borrow 1157 41 cents against it. Stop and think. If the cost of capital is 10%, what will be the present value of $1,000 to be received after 5 years? So if you surrender that $1,000 after 5 years, a bank that wants to earn 10% interest on you, how much will they be willing to give you? So you got to discount that $1,000. Is it 1,000 divided by 1.1 to the power 5 or 1.01 to the power 5? The correct answer is the third one, because it's 10% interest. This is if it is 1% interest. So that's 621. So $1,000 coming after 5 years, the bank, if you surrender that to a bank, will be willing to give you $621 only today. But if this was 20%, this number would be even less. Okay. Now let's go to net present value, the NPV. How should the incremental value analysis, which ignored time value of money, be modified to accommodate for the cost of capital and time value of money? Recognizing time value of money, so you shouldn't look at cash flows just with a nominal amount. You should say, when is it coming? The sooner it comes, it's more valuable, because against it I can borrow more money from the bank. So you convert all future cash flows into the present values, now using the weighted average cost of capital as your R, as your discount rate. Then you subtract the initial cash outflow. So initially you needed 138,800. So 20,000 you were putting, and the bank, you were borrowing from the three sources 118,800. So now all of that is in today's dollars, right? But then the business is going to give you future cash flows. So you say, oh, I surrender all that, and you discount them to find what is the present value of all those payments, and then you see, is that more than the 138,800 you need? Then you choose the option with the highest positive NPV. If there are two options, find the NPV of the first one, NPV of the second one, and choose the one with highest NPV. If all NPVs are negative, then you choose the status quo. So here is what we did before, right? So they are slightly different here. We don't calculate any interest cost, because that's all subsumed in this, the way we handle the time value of money. So we basically upfront we are borrowing 118,800. We are putting our money. So this is the amount of money we are putting into the business. But your cost of capital to borrow this is 20.57%, your weighted average cost of capital. So that is your R. So here are your cash flows. Note there's a lot of money coming in year 5. We didn't have any opportunity cost of time, opportunity cost of resources, but a significant difference is there is no opportunity cost of capital or cost of capital. It's all subsumed in this analysis. Instead, what we say, okay, if I surrender this payment, and if the bank is trying to make this kind of return, how much will it give? And that's 78,440 divided by 1.2057. That's 65,057. You can borrow against this. Then you surrender the second payment. It's coming after the second year. So it is 95,870 divided by 1.2057 squared. And that's 65,947. You can borrow against this. So that's the present value of this. This third payment is 113,300 divided by 1.2057 to the power 3, to the power 4, to the power 5. So interestingly, you see the nominal amount is the same, but you can borrow more against this because it's coming early, right? And this is coming later. Here you are able to borrow more because there's a lot more money here. So particularly note that this is very important, because most of your money that you need is upfront. That is already in today's dollars. But most of the money that business is going to give you is down here. But that's coming after 5 years. So when you discount it, that value, you see the 160 became 62. So finally the net present value is you calculate how much you can borrow against this, how much you can borrow against this, you add all this, and you find that is 170,244 more than what you need. So that is the net present value. So the business, if you surrender the future cash flows, you can borrow way more than 138,800. You can borrow 173,244, and that's called the net present value. So that is the right way when we consider time value of money to do the analysis. Okay. What is the meaning of the NPV number? So okay, what is the meaning of the NPV number? So NPV is replacing our incremental value, right? So it's very important we understand the meaning. So net present value is basically the incremental value, but adjusted for the time value of money. Before, we just added all the cash flows without taking into account when the money is coming. But now we adjust all future. What comes after first year, we convert into present value. What comes after second year, we convert. And so net present value is basically incremental value adjusted for the time value of money. Another way to look at it, it's also the incremental cash flow beyond the startup cost. A decision maker can borrow today by surrendering all the future cash flows to a lender who wants to earn an interest equal to the discount rate. Okay, so in our case, NPV is the amount in excess of what you need upfront, the 138,800 you can borrow. Calculate NPV if cash flows from year 0 to year 5 are as follows. So you have to spend $10,000 upfront to buy as a startup cost. Then first year business gives you this, and every year it's giving you $1,000 more. What's the NPV of this? Remember, you got to discount this to see if you surrender this, how much you will get. Surrender this, right? Is it 653? Well, the answer is cannot be determined, because to do NPV, you need a discount rate. You need to know, we assumed earlier it was 20%, but here it's not being specified, so it cannot be determined. So now we come to internal rate of return, which becomes useful when you're unsure about the discount rate or the cost of capital. What do you do when you're unsure about the cost of capital? Because remember, to calculate your weighted average cost of capital, in real world, you need to know what a bank is going to charge, whether the bank is going to give you a loan, and what is your opportunity cost of capital, and what is a credit card company going to charge you, and then the angel investor. So sometimes you may not be sure exactly what your cost of capital is. But then to do NPV, you need the R to discount the future cash flows. But what do you do if you are not sure about the R? Right? Estimate the discount rate at which NPV equals 0. So what you do is, okay, try a discount rate, and NPV becomes positive. It means it is telling that at that discount rate you can borrow more than what you need. Well, then try a higher discount rate, and then you find the rate at which NPV equals 0. So what does that mean? If the lender is going to charge you that rate, you will just break even, right? You will be able to borrow exactly the amount that you need. So if you come here, so suppose we didn't know this weighted average discount rate for sure, so then we couldn't have calculated this line. But what we can do is we can put different numbers in discounting these cash flows. See, currently when we put 20.57, all of this is more than this. So you use a higher number. Then these numbers comes down, this number will higher number, until you drive this to 0. So this graph is telling you, see, currently we are using 20.57, and the NPV is 173. If you use a higher rate, it starts coming down. Now if you don't use any rate, it will be so high there. As you use a higher and higher rate, it comes down. Finally it hits 0, and that is 63.75%. And there's a simple way to calculate this. There's an IRR function in Excel. You simply say equals IRR and you sum this whole line, and it will tell you it's 63.75%. But this is basically what Excel is doing. You're currently here. If it's positive, it tries a higher rate. Positive, tries a higher rate. Then if you tried too much, you became negative. It tries a lower rate until it drives NPV to 0. So in our case, it's 63.75%. So basically it says, if you surrender all your future cash flows, even if a bank wants to charge you 63.75%, you'll be able to exactly borrow what you need. But if they want to charge you less, then you are a winner, right? Because you can see if this is your IRR, but if your cost of capital is below that, then when you use that number, your NPV is going to be positive. But if your cost of capital is above that, when you use that, NPV is going to be negative. What is the meaning of the IRR number? IRR is a cost of capital in which present value of all future cash flows exactly equals the initial investment, right? And so it is also called the implied rate of return. It is the return implied by your business, right? And so the decision rule is, if IRR is less than weighted average cost of capital, so the return by the business is lower than the cost of capital, obviously investment is an unprofitable one. But on the other hand, if your IRR, like in our case 63.75%, is much higher, so even though we may not exactly know the weighted average cost of capital, we may know the ballpark. Well, it's between 20 and 30, but in our case IRR is 63.75, then we know investment is profitable. The higher the IRR, the more profitable the investment is. So when you calculate your IRR, and if it's a very high number, well, that shows your business is profitable, is giving you a higher return. So capital costs you WACC, but then when you put that, business is making this much. Okay. Calculate IRR is the same question as before. If we are going to require $10,000 initially, and this is what business makes. Now calculate the IRR. Remember, we couldn't calculate the NPV. Can we calculate the IRR, or this also cannot be determined? Surprisingly, you will find the correct answer is 12%, because this IRR equation in Excel, you say equal IRR, then you add this whole thing. So then Excel goes to work, and it says maybe it tries 8%, and then you find this is positive. That means it says if it's only 8%, you can borrow more than 10,000. Then it tries a higher rate, and you will find if you try 12%, this would exactly, if you surrender this, it would exactly be equal to 10,000. In other words, the return by this stream of cash flows implies the implied rate of return is 12%. Okay, and in class we will apply this to our business.